Hey man, what's up? And
Hey,
hello to everyone out there, and welcome to the first episode. I put a sneaky episode out just before the holidays, but welcome to Code to Cloud. And today we're going to be talking about what- recompiling the kernel or improving Linux performance in general for container workloads, right? With the one and only Guil Lima. Gil, do you want to introduce yourself?
yep. My name is Guil Lima. I'm a cloud solution architect for Microsoft Canada. I'm part of the infrastructure team. It used to be called Azure Core, but now it's just infrastructure again. And I'm always working, helping our clients improving their performance, reliability of the environment, especially for Unix servers, but also deeply on cloud migration and also BCTR solutions.
I mean, I work with Gil on a daily basis. This guy is just a volcano of knowledge when it comes to technical stuff, right? So I'm really interested to see how this works. I know he's got a big passion for open source and Linux technologies, right? And if we, and I know you could probably go through this in the deck, right? But if we roll back the clock 10, 15 years, Linux was Apache servers, right? Linux was, running, web backend services. Now it just seems to be everywhere, right? And Microsoft has fully embraced it as well, right? So I'm going to hand over to you, Gil, and we'll get started.
Yeah. So let me share my screen for a second.
Go for it.
Okay.
And here we are. Awesome.
Yeah. So today we are here to talk about improving the performance for containers. Not necessarily just for containers. We can use the content that we'll be presenting here basically for everything, but I'll be going to present some advices and some features that I could test preparing my environment for containers in the past. And those performance improvements that I could implement help me with the performance of my servers and also saving some resources so I could have more containers running the same hardware. So, and there are multiple ways for us to accomplish that. And one of those ways would be recompiling the kernel, but we can also work with the environments, the variables for the environment, customizing some custom features. And there are some changes that we can do in the OS that always help to improve the performance. About the content that we'll be talking today, we'll be talking about a little bit about myself, what is Linux and how it works. We will be talking about the Linux kernel, how to do performance improvements, and a quick demo on how we can implement those features in a live scenario.
Awesome. Everyone loves a demo.
Talking about myself,
Yeah.
yeah,
Go for it, Gil.
talking about myself, I'm a cloud solution architect here in Canada. My background before becoming a cloud solution architect, I used to be a virtualization consultant, but I used to be also a Unix specialist, an infrastructure consultant, and also in the many years ago, I used to be a field engineer for AP and Unisys back in Brazil. And a few of the companies that I worked for as a consultant, I've been working for lots of companies, but the main ones are Microsoft, Apples, Accenture, ArcelorMittal, First One IT, FreeBSD, Unisys, and HP. Now, let's go to what is the interest of this presentation. Let's talk about the history of Linux. So before we know where we are going, we need to know where we came from. And in order for us to do that, we need to have an understanding of how things start. So different people have different mindset on how to approach solutions. And the reason for me to love Linux, and not just Linux, but also any Unix solution, any free solution that we can use that use open source code, it's because every time I have an issue in my client's environment, in my own environment, I like to know what is the source of that issue. So why that issue started, what can be causing that issue. So in order for me to do that, I usually go a bottom up troubleshooting method. So I know how the solution works in the background. I know what libraries it's using, what are the configurations that I had to implement in order for it to work, and then what is the impact of each one of those changes, and then I know the impact of those changes in my environment. So if I see an error in my environment, let's say, for example, an error 404 in my web application, I know what kind of error is that. I know what causing that error, so I have a straightforward mindset troubleshooting that error. And the best way for us to do that is when we have a deep knowledge since the source code, how the connections work from the hardware until my app in the front end. And then in order for us to understand that from the Linux perspective, we can start from 1977, talking about BSD. So it's a distribution that was released in the University of the California. The BSD was one of the first Unix solutions that was developed. And moving forward, in 87, it became Minix. It's a Unix-like system. It has an open source code, but has it's restricted from modification and redistribution. So there are some constraints about that, and that caused some changes in the market. So, for example, in 1991, Linus Torvalds, he got his first personal computer. It was running MS-DOS. It was the primordial of Windows, and he wasn't happy about how it worked. So he took the GNU. It was another Unix distribution that was released in the 80s, and then he took that as a source code for his own OS, so his own operational system, and he started the development of Linux itself. So he started the development in 1991, and he released the code in the internet at that time, and it caught the interest of many people that were also not happy about MS-DOS, and that those guys decided to work together to improve that kernel and develop a brand new system. And then, since he released the code to the internet and start getting some interest of people to help developing that code, in 1992 he opened his code under the GPL. It's the GNU public license that was developed by Richard Stallman. Richard Stallman is the guy who developed the GNU Unix in the 80s, and he developed a public license where everyone can release the code, and that code should be open for everyone. The source code should be redistributed, and also everything that was developed using that source code should be also be free and available with the source code, and also should be free for redistribution. So that way, Linux became a real open source solution. And then in 1993, Slackware became the first widely adopted distribution. Slackware was the first distribution that came with the Linux as a base system that was widely spread around. And then in 1996, they choose the penguin as the mascot for the Linux. And it's also the same year where the version 2.0 of the Linux kernel was released. In 1998, um, brand, big companies decided to provide support to Linux like IBM, Compaq, and Oracle. In 1999, Red Hat goes public. It's one of the most widely distributions right now. That's in parallel with Ubuntu, SUSE, and many others. And then in 2002, the first commercial version of Red Hat was released. 2004, Ubuntu was released. And in 2005, Linus Torvalds, the same guy who developed Linux, created Git. And most of the guys who work with containers use Git in a daily basis. So I would say it's as important as Linux right now.
I didn't
And
know. I didn't know he invented Git.
yeah,
Or he helped create
in
Git, right? I
2005.
mean, Git's used everywhere now, right, as a source control. So we've got a guy who developed the Linux kernel, and he also developed Git, right? Like, that's crazy.
Yeah, this guy is he hit things outside of the box. He's in
Sure, for
another
sure,
level.
for sure, right?
Yeah. In 2007, Linux Foundation is formed to promote the project and standardize Linux. Kevin and I, we are both part of the Linux Foundation. We are always presenting here in Calgary, especially about containers, but we are under the umbrella of the Linux Foundation, talking about open source solutions. In 2008, Android OS was released based on Linux V1. In 2011, version 3 of the kernel was released, 2015, version 4, 2019, version 5, and 2022, version 6 of kernel was released. This is the newest version that we have available.
So I have some questions, right? Because like I'm looking at some of this, and I feel like I'm getting old because I remember some of these names, right? So like if we talk about Slackware, I remember when I was in high school, like I started off a Red Hat, right,
Yep.
before it became Fedora. And I think it's key for us to try and clarify what a distribution is. So one of Linux's strengths is that you can create your own operating system.
Yeah.
But it also means there's a lot of flavors of Linux to choose from, right? So you've mentioned some
That's
names like
correct.
Red Hat, right, is one of the biggest enterprise ones out there, right? Like, and they have Fedora, right, which is their bleeding edge distribution, right, which you can download for free and everything else. I believe you can get a copy of Red Hat Developer Edition as well, but you can get Fedora as well. But
Yep.
then Ubuntu, right? That's like, I didn't realize this, but Canonical, who develop Ubuntu, I believe, like, I don't know about you, Gil, but before the internet, right, and we had the bandwidth and everything, you used to be able to go on Canonical's website and they send you a free CD with Ubuntu on it, right? Like,
Yeah.
they used to send you some stickers in the mail, right? I just remember like putting Ubuntu in, and like it's one of the most community friendly ones. But like Slackware,
Yes.
I remember like that was Slackware and Debian were like the big ones of the time, right, in the 90s kind of thing. So, but yeah, I didn't know he was involved with Git. Like, that's something new that I've learned today. And then we've obviously got Android, right, which is, I don't know how much of the
Yep.
market share of cell phones, right, or smart devices, but it's out there. That's
I
all the
think the
way
last
back
news I
from
saw it was 70%.
70%.
The market, yes, 70% of the market share. The last news I saw it was 70% for Android and 30% for iOS.
We won't get into the Android versus iOS battle here on today's session because we will be here for some time. But ironically, iOS is built on Unix. So is Mac OS, right?
Yes.
That kind of thing. So all
I
started
don't
in
bother
90s.
in the about the competition.
Pardon?
iOS is Unix, and I don't bother about the competition because either way I'm happy.
Yeah,
iOS is
because
Unix,
same ecosystem,
Android is
right?
Linux, so it's
Yeah.
all so open source. Yeah.
So awesome. I'll let you carry
But
on. I've
talking
loved
about the
this.
distribution,
Yep.
yeah. So talking about the distribution, this image here helps us to understand how the distributions work. So we just talked about the license. All the Linux are under the GPL, so they have the open source code. They are free to use, free to change, free to share, and redistribute. And the way that works is basically all the Linux, they have the same kernel. Some of them have a few customizations here and there, but the source code is the same. If you go to linux.org and download the kernel, it doesn't matter if you have Red Hat, Ubuntu, SUSE, you can compile the same kernel and it should run in all those flavors of Linux that you have. Because what happens is, when you talk about the design of the OS, it's a simple design. I'm going to start simple and I keep moving forward and make it more deep dive just so I don't mess up with everyone's head with how my mind works. I usually go really deep on my study, but let's start simple. So when you talk about the computer is composed of hardware. We have CPU, disk, memory, I/O. I/O could be anything. It could be a printer, a keyboard, a mouse, anything that you connect to your computer and it provides a signal to your hardware. It could be considered an I/O. And then if we have just the hardware, it doesn't do anything unless you have something to translate the hardware to a language that we can understand. In order for us to do that, we have the kernel. The kernel creates the communication between the human language and the hardware language. So it's a set of libraries, a set of um, components that will create that connection between the hardware and the front end. And then the Linux kernel is shared between all the distributions. Doesn't matter the flavor that you choose. But then you have the shell. The shell would be the level where you have the OS itself. So when you have, for example, Red Hat, the shell of Red Hat provides you a book of features that we can use. For example, you have Yum for the package management. And you have customizations about libraries that you're using, environment variables that your comes by default in your system. When you go, for example, to Ubuntu, it has another set of environment variables. It has another set of libraries that it's going to be using. So all of those kernels, all those flavors, they share the same kernel in the background, but with a different front end. So, for example, if you're compiling, if you need to install a package, some of them you can use RPM, some others are going to be using yum, some others apt, some others are be using zipper. So compilers are different between those distributions, but it's a different way to translate the user commands to the hardware on the background using the kernel as a middleman. So that's it, how it works. And then the last level, we have the application itself. So the application, it's a solution that's going to use the shell to translate commands to the kernel, and the kernel is going to translate those commands to the hardware, and then vice versa. So hardware, based on the commands that it's received from the kernel, it's going to process everything in the CPU and memory and move the results back to the kernel. That's going to move the results to the shell, and that's going to move the results back to the application, and your application is going to present those results in the screen. So it sounds complex, but it delivered on me. It's the easiest way to show that kind of information.
I love the diagram.
Now,
So,
as I said,
so go for it. Sorry, there's a delay, right? I keep talking. Sorry. Go for it.
no, go for it.
No, I was just saying that diagram was like if we look at networking, we have the OSI model. That was like the OSI model for operating systems. I kind of liked it.
Yeah, yeah. And then when we move deeper down, we have here the same diagram with a different perspective. So we keep moving deeper on that process. So at the bottom, we have the hardware, would be the CPU, memory, storage, I/O device, anything. And then in the next level, we have the kernel level. So in the kernel, we could be using Unix, we could be using a BSD solution like FreeBSD, Butterfly BSD, OpenBSD, or anything else, HPUX, AIX, Solaris, and any other. And then for this case, for the purpose of this presentation, we're going to be talking about Linux. When we talk about Linux, we have three layers here where we have the solutions that are part of the kernel. So we have, for example, the device mapper, we have the network schedule, net filter, we have the Linux security modules like ST Linux and any others like App Armor. But moving one layer up, we have the processing schedule system, we have the IPC system, memory managed system, virtual file subsystem, network subsystems. Each one of those subsystems take care of part of the communication between the front end and the back end itself. And then we have a few commands that are both basic commands that creates the communication between your application level layer and your kernel layer. So we have some commands, for example, write, mmap, close, exit, read, write, and stat. Those are the commands that your applications are going to be used to communicate to the kernel. So those are the front end layers of your kernel level. And when you go to the user mode, you have the C standard library. We have another set of commands, so over thousands of commands that we can be using. So for example, we have commands to open a file, to customize a file, to check the timing of your CPU process, and you can check your system status. We can write and read files using the C libraries. And then we move to the system components. That is the next level. So we have the daemons, we have the system daemons, we have the Windows management. So when we talk about, for example, the flavors, some flavors use X11, some others use Wayland, Surface Finger for Android, and many others. When we talk about graphics, we could be using AMD, Catalyst, we could be using Intel, and we also have another set of libraries, for example, GTK, KT, EFL, and many others. And the last layer is the user application. So it's the layer that we provide those commands to the system. So we have bash, that is your command line that you have for your system. You have the LibreOffice, that is the equivalent to Office for Linux. We have Blender, we have Firefox, and you can use any other solution in your user application level. And then that communication would go to your system component, that would go to your library, that would go to your kernel, and that communication would go to your hardware.
Awesome.
And this one, it's here just for fun. if you want to know more deeper down how those communication will work. So for example, you have one column for system, another one for processing, memory, storage, network, and the human interface. And then from each one of those, you can see the communications between each one of those layers. So for example, in the user space, you have things here, for example, sysfs that communicate to sysops, that communicate to a subsystem registry, that communicate to the bus type, and that way you can go down until you reach your electronics. So it goes on the left side up to bottom. You have the user space interface, virtual bridge, functional device controls, hardware interface, and the electronics. So for the hardware interface, you have the drivers. In the device control, you have the libraries that connect to those drivers. For the functional layers, you have the process that create the communication between your application and those drivers itself. And then in the bridges, you have the synchronization, memory mapping, page cache, swap, and network and storage. And then moving up, you have the virtualization layer, and then you have the user space interface. I
I
know
mean,
it
there's a
sounds
lot.
complex,
That is complex. I'm reading that now, right? And I'm going like,
but it's fun. I like this kind of diagram. It blows my mind when I see this kind of connection. And sometimes we don't have the visibility of if you do a command like ls to list the content in your screen, you don't know what happens in the background, but it's
yes,
lots.
yeah.
And every day it's just getting even more complex. And then when we move to the performance monitoring for the Linux systems, we have a similar diagram. Again, now we start going back to something more simple so I don't blow everyone's mind. Let's try to make it as simple as possible. We have some commands and we can see where each one of those commands would apply to your system. So for example, you have the application layer here on the top. And for the application layer, you have commands that you can get information from that application layer. For example, trace you would trace information from those packages. You have nstat, it would get status from your networking device, from your sockets, from your IP and your net device. You have TCP dump. TCP dump, it's one of the most important packages that you have to troubleshoot performance. If you want to correlate TCP dump to a Windows solutions, Wireshark would be the closest that we have. So you would be able to see all the packets flowing through your network interface, and then we can filter those traffics by source, destination, port, connection status, and basically anything. Sometimes when you have a networking issue in your environment, TCP dump it's one of the most handy tools for you to troubleshoot network connections and understand, okay, there is something blocking my connection. What resources blocking my connection? Is that my firewall? Is that my network interface? I don't know what package that is that. So this is how you can um, troubleshoot that kind of scenario. When you talk about disks, for example, we have, for example, IOStat. IOStat it's like a top, like a task manager screen where you can see information about your storage device. So, for example, reads, writes, number of packets, and all of that kind of information. And we have also perf. Perf would provide you information about CPU, memory, disk, and everything for environment. You have free, where we see information about your memory utilization. We have nixstat to get the status of your network device. If you want, netstat is also important for you to troubleshoot the communications to your port. For example, you have an application running on port 80 or 443. You can use netstat to see the status of that port, to see if it's open, if it's listening, if it's closed. So for example, sometimes your application is running, but you forgot to enable port 443 to receive connections. So you need to, it's an alternative for you to troubleshoot that kind of scenario. So that just are some of the important tools. Just a few more here. Top provides you a task manager view where you have CPU, memory, and process utilization. It's really important. You from top you can see those pieces of information, but you can also queue process, for example, and PS also shows you the status of the process that are running in your computer. Now, moving to the container side, when you talk about containers, it's important for us to understand the difference between virtualizations and containers. So one more time, going back in time, when we started using computers, computers were expensive. computers were not as productive as they are today, and they are not as powerful as they are today. So in the past, for example, I can give you an example. My first job was a service desk guy in 2006, and we had one server in the company. It was an HP server, and it's used to run Active Directory, printer server, file server, and directory server, and everything in the same computer because they're expensive, they are hard to manage. You have to pay for the hardware, you need to pay for the license for the OS, you need to have people to manage those operations, and you need to patch those servers. So all of that, there's some workload involved on that. So everything used to run in the same server. So it was more simple from the hardware perspective, but it was much more complex from the administration perspective. Every time we had to do any kind of maintenance on that server, let's say, for example, we had to update the driver for the printer device. We had to restart that server. Could not do that during the day because it would impact everything for the company. So it was hard to find a window for maintenance because some of the processes under that company, for example, for the file server, they were 24 by 7, so they were running all day long. So it makes complex to give maintenance to those servers. So that brought the virtualization concept. So the virtualization concept, you got OS, that was what was being used up to that point, and then create another layer for the hypervisor. For hypervisor, we have lots of brands in the environment right now. We have Hyper-V, we have VMware, we have OpenBox, and many other solutions that you can use. So the hypervisors create another layer on top of your hardware. So you create virtual hardware on top of your hardware. So when you have that, you can have one big hardware, and then on top of that, create multiple small hardware segmented by application or by a segment under your company. Doesn't matter what you do. What is important is segment or environment. So after we implement the hypervisor in that company, we used to have a server for Active Directory, another server for a file server, another one for printer server, and yeah, as many as we need. So every time I had to do an update for the printer server, I just had to send a message to everyone, hey, everyone, we're going to do maintenance for the printer server. It's going to be off for 20 minutes, but it's going to come back after 20 minutes. So just don't print anything for now. And then everyone, okay, yeah, I can hold 20 minutes for to use my printer. And then we could do that maintenance. Some others, like the file server, we could create redundant servers. So instead of just one, we had two. And then they were using a shared disk. So every time I had to do maintenance, I could take over the disk to the second server, do the maintenance on the first one, and then move it back, the shared disk, the first server, and do the maintenance on the second one. So it was another benefit that came from the virtualization as well. So it makes it more easier and cheaper for us to have shared hardware. Because, for example, in the past, sometimes we had like a huge server. It was like $50,000, and then we were using like 20% of that hardware. When we have virtualization, we have a better management. Sometimes we know that this server A has more utilization during this part of the day, and the server B, it's overnight, for example. So we know that we can share the same hardware because they are not competing at the same time. So using the same hardware, we can have more things running, and you can keep your hardware utilization, let's say, around 60 to 80%, and it's healthy. And compared to before, you would keep part of the day your hardware running like 20% of its capacity for some parts of the day. And then that is the high-level explanation on the virtualization side. But then moving forward, we had the need to improve that scenario even more. And then that's where containers came from. So when we talk about containers, we take our operational system and we create subsystems on top of that. The way it works, let's say, for example, we were talking about the kernel and libraries that run that
Yes.
kernel. Those libraries and those packages, they can be shared. So why would I deploy a brand new OS from scratch every time I need to scale up my solution? So for example, here, let's say, for example, in my virtualization side, let's say I have my app running here on this server. I have one OS and one app running for that app. If I need to scale up my solution, I need to deploy another OS and another app. And that process of deployment, it is deploy the OS, deploy the application, implement all the security package, harden that server, and then put that server online. And that process takes time. That process creates breaches in your environment from the security perspective. and that process, it's complex and demands a lot of resources. Because, for example, let's say if you have 10 servers running the same application, you have 10 OSs in parallel running similar process for all of them. So you're using much more storage because you have the same process, the same libraries in OS and kernel 10 times. Every time you need to patch your environment, you need to patch your environment 10 times. So it's complex, and we don't have that kind of freedom right now. We need to make everything more simple right now. The word it's agile, so we need to make it agile. And the way that we do that, it's creating the container. The container, it gets your kernel, your libraries, and share those libraries to all the sandboxes inside of that hardware. So let's say, for example, you have your app, and that's composed of its code and its libraries. And then we need to deploy a second container for that app to run. What you do, you just share the kernel and your libraries to those two containers, and they use the same base layer to run the application on top. So you have, when you deploy you need to scale up, let's say, a third app server running that application. You just say, okay, this is the code. I need one more container running that solution. This is the base kernel and the library that you're going to use. Just spun up. So instead of deploying the server, hardening, and everything, you just deploy the code and say, hey, those are the libraries that you're going to be using. So this is how containers work and how they make everything more simple. Instead of deploying a brand new OS from scratch, the OS is shared between multiple resources, and you create rules for scale up, scale down, connections. You can say, for example, this container is read only, this one is read write. So you can create customization for those containers to make them more safe and more isolated or more open, depending on the scenario that we're working on. And you also create a virtualization for the networking device. So you can block the connections between one container to the other, but sometimes you can say, okay, those containers can communicate with each other. So for example, here in this graph, you have the OS in the base, and you have two apps running. And let's say on the left side, you have a networking connection where those two container apps, they can communicate to each other, but they are isolated from these other three. So it could be two different applications running on top of the same hardware in two container scenarios that are isolated from each other. Clavin,
That's awesome. Yeah. So
say if I say something wrong.
no. So let's just summarize this, right? So, like you said, tin servers are expensive, are still expensive, right? So to work them harder or get more return on investment, we introduced virtualization, right? So we introduced that hypervisor layer, and that allowed us to create virtual machines, right? But they would have their own isolated operating system on every instance of a virtual machine, right? So it's another set of licensing. It's going to take up more cores. It's going to use more memory, etc., etc. It's more to manage. But with containers, and I just wanted to emphasize the shared kernel model, right? Because there's obviously Windows containers and Linux containers. So you, depending on the host operating system, depends what container runtime or operating system runtime you can run, right? So we're basically sweating the assets even more, right? So we're breaking that down further. We're removing the hypervisor layer and we're just running a runtime engine, right, for the containers. So we're just running our apps, right? So we're able to run more apps on less hardware.
Yep.
Okay, that's awesome. Great overview.
Now, let's make this interesting.
Demo time.
So it's demo time. So just before we understand what are going to be in the demo, let me just give you an explanation on the reason of for us to do kernel optimization. So let's talk about the benefits of the kernel customization and optimization. So when they develop Linux, every time someone's developed an OS, that OS they try to make that reliable and efficient, but also compatible. In order for you to make an OS compatible, you need to provide support to almost everything that is available in the market. So, for example, you need to provide support to AMD processors, Intel processors, and you need to provide support for all the kind of brands of memory that you have available. So different frequency, different brands, and they work a little bit different from each other. So you need to have a driver for those resources. Let's say, for example, for a printer server, you need to have drivers for HP, for Dell, for any.
Yeah,
Dell doesn't create printers, but you got what I'm trying
I
to
know what
say.
you mean. I know what you mean.
But you need to provide drivers and support for everything that is available in the market. So keyboard, mouse, headsets, and sound systems, and video cards. So we have lots of video cards available in the market. So you need to provide support for all of those video cards. And then every time you create and add more compatibility to your server, it creates an overload. So you are loading modules and you are loading configurations in your system that you are not actually using. Because what happens is your computer, when you deploy a brand new kernel, a brand new, let's say Ubuntu or Red Hat to your environment, when you connect a brand new mouse, it needs works right away. You are not expecting to recompile a kernel to add a mouse. So the module is there and it's ready to go. So, but because that module is there, it's consuming some CPU, some memory in the background. And when we talk about containers and when we talk about return of investment abroad, we need to make your environment as performant as possible. So the first thing that we do is remove unused modules. Sorry. When we talk about virtualization, when we talk about cloud solutions, let's say, for example, Azure, AWS, Google, and any other Oracle, when you talk about those cloud solutions, for example, if you go to Azure, you know what flavors of hardware they have. Even though moving from, let's say, most of our clients, they have a set of SKUs that they run their servers. There are SKUs that are more CPU efficient, some other memory efficient, some others are more storage efficient, some others are for the batch processing. But it, it's going to change from flavor to flavor. But most of our clients, let's say, okay, for containers, we are going to be using, because of the nature of our solution, we are going to be using just memory enhanced servers. And then from the memory enhanced servers, you have, let's say, 10 different SKUs that are going to be using. And then when you map those 10 SKUs that you're going to be using, you can map, okay, those 10 SKUs, they have similarities. So they have the same CPU family. They are always Xeon processors. They have this memory set. So they have these flavors of memory that they're going to be using. And they have this part of I am not going to be using sound devices because my application doesn't need sound. It's a server. No one will be listening to Spotify on it. So I can remove that. I can remove, for example, a wireless card because no one is going to be using wireless on Azure. I can remove many other features from those servers that are not going to be used. So when you remove those modules, the first thing, you accelerate your boot process. So every time you need to patch your server, it's so much faster. It reduces your CPU and memory utilization, both in idle and in use. Because if your computer just stopped, I did that test many times, but I redid that test last week again to make sure that I'm not seeing anything wrong. In my computer, I deployed a brand new server and I had some applications running to create a fake scenario. And the memory utilization in my server was 1.2 GB. And then after customizing my kernel, removing a bunch of modules, it reduced to 800 MB. So I saved 30,
Oh
40%
wow.
of my memory utilization idle, just removing modules that are not in use. You need to take care. You need to know what you're doing. That's why it's important to understand how your kernel works and what it's in use by your hardware and by your application before you do that kind of change. I will be showing here in the demos a simple customization that we can do, but I recommend everyone to spend more time after defining what flavor of Linux you're going to be using, what kind of application you're going to be using to, to improve your code. But the next step, it's even more important for me because I also have a security background. And when we talk about the security background, when you implement this kind of change in your environment, you do a hardening in your environment and you create a bug fix. The reason for that is every day there is a day zero for a brand new vulnerability, and those vulnerabilities are going to explore something in your environment. It could be bad code that was developed by your printer driver, and they use that vulnerability to grant access to your system. So if you have libraries and apps installed in your server that are not in use, even though they are not used, they are ready to be used at any time. So as I said, you need to connect your mouse to your computer and it should work right away. So that's an example. If there's a day zero for that mouse driver and that day zero comes up, if your server has that library available, someone can use that vulnerability to access your environment. So when you do the hardening of your system, removing everything that's not in use, you're removing stuff that you need to be concerned about. So that is the principle of hardening. So try to create your environment that is simple to manage and where you have um, just what you really need in order for that application to run. And then another benefit is to support the kernel development. What I mean about that is, for example, if you're, I was testing the Linux kernel 6 in my environment, and I faced a few issues. Everyone faced a few issues compiling a kernel sometimes. And then I was reading the documentation. I was in the Git repo for the Linux kernel, and I was reviewing some comments there to what I can do to fix those issues. And I was also commenting on those. Okay, I faced the same issue in my environment. I am, let's say, on Reddit, and then I saw with someone with a similar error, but I could fix mine myself. And I posted there, hey, I had a similar error. You can change this configuration and it should work. Try it, let me know. And then I help someone else to recompile their kernel. So you're supporting the community development as well. So it's another important level of this kind of customization.
So,
And then,
sorry, just go back. I thought
yeah,
this was a really, really important. So, less is more. That's what we're saying right here. And we're also saying,
yes,
we talk about security a lot, right? Attack surfaces, that kind of thing. By making the attack surface as small as possible, you're making it harder for the bad guys, right? So, this is some good practices, right? I know a lot of people do this with their container images as well. Like, only deploy what you need. Like you just said, like if I'm spinning up a VM in Azure, right, it's running Ubuntu. Why do I need a mouse driver?
yep,
You're just going to be using the command line interface, right? I just need the keyboard, right? That kind of thing. So trying to go in with that mindset is only going to make things better for you.
yep, 100%. And when you talk about security, it's important. In the 70s, if I'm not wrong, they released a series of books that's called the Rainbow series. That's like um, a set of rules in order for you to make your computer environment more safe and more like a best practice guide.
Right,
And
right.
one of those books is the Orange Book. The Orange Book is focused on security and hardening. And believe me, a book's from the 70s, and there are some best practices that we shouldn't have implemented for everyone. And it's mind blowing that someone had those ideas in the 70s. And I recommend everyone to take a look at least on the highlights of that book because it's really important. And one of those highlights is to make your environment simple. And when you talk about security, one of the key principles of the Orange Book is defense in depth. So when you talk about defense in depth, you need to think about every layer of protection that you improve to your solution. It has an on payload for that. What I mean is, for example, when you are protecting your environment, let's say, for example, just I'm blocking this set of IP addresses. It's simple, it's easy, it's not going to take a lot of CPU and memory from your firewall. But if you are analyzing the package to see, for example, if a SQL query has a command that is not expected to be used, for example, let's say you're expecting a username and password, and someone type a select on your SQL database. You need a solution like a web application file to read what is coming up in that query to understand if it's a valid query with a username and password on it or it's not. Your solution, your firewall would need to go and see the IP, the port, the code, and then what is the layer 7 of your package in order for you to understand what is coming on from that query, and then to say, okay, it's allowed or not. It takes a lot of CPU and memory. If you look for the OZ layers, if you are checking just IP address, you're going to layer 3. If we're checking the port, you're going to layer 4. If we're checking a query inside of a variable, it's layer 7. So your payload is huge. So when you make your environment more simple, you're reducing the payload for your security levels. So if you, for example, you are removing your wireless driver in your mouse driver, you don't need to create a layer of protection for mouse and wireless attack in your firewall in the border of your network, because you don't have that kind of vulnerability in your environment. So you don't need to be concerned about that kind of attack. So this is how it works.
Okay, awesome.
Sorry, I'm going to deep again. So in order for us to start your demo, everyone is bored of seeing this presentation and probably want to see a black screen in front of you. So the first thing that we need to do, you can find kernels and you can find configuration files available on the internet with some customizations ready. But if you want to go deeper dive and you want to make sure that you are using something that comes from the source, so you don't have any customization that be harmful to your environment, I recommend you go to kernel.org, and then from there you can get the latest version of one of the previous versions of the kernel from a safe source. So the first thing that you need to do is go to kernel.org. Let me bring that here in the screen so you can see how it looks like. Just 1 second.
I think I went to this website back in the day, right?
Yeah,
But it was just
it's
text
super simple.
based. Yeah, it was text based at the time, right? It's got a
Yeah,
few images now, right? But
yeah. So from here, you can download, for example, you can go here and copy the link address of this one that is the latest version.
right,
But some people, for example, I have the mindset of N-1. So I usually don't go for the latest version because in my mindset, it's more vulnerable. So I usually go one layer down. So for example, the most stable one is 669. If you are looking for the long term one, I would go 617. It depends on your environment, but there is also 67 RC8. I would say I would go for the stable one, but just because it's my comfort line, it's where I feel comfortable deploying my code. So you can get the 6.9, but if you want to go nuts, you can go 6.7 as well. I'm not that crazy anymore. In the past, I used to compile kernels for fun. So every time there was a brand new kernel here, I would go and deploy that kernel and like I would deploy a 669 and a 67 and compare the difference between of those. I would do a test to see the performance change between them running the same application for CPU, memory, and to see I stress test to compare the results. And I would run a few chains on them and compare. Okay, the same chain applied on those, there is more or less performance in one or the other. So I used to be that nuts. I'm not like that anymore. I don't have that kind of time available
free
anymore, but
time, right?
it is
Like
what it is.
it is what it
Yes.
is, right?
And then the next thing that you need to do, you're going to extract that code and you are going to install the required package. I have here a list after testing running. I was testing the 6.7. I was testing the latest one in my computer. I got the brand new Ubuntu server. And after a few tests, those are the packages that I mapped that would be required in order for me to compile the kernel. If someone has interest, please reach out. I have my contact in the last slide. I can give you this list, or you can take a print screen of this here and you can download those packages yourself. But the most important ones here are the dist upgrade, the Bison, the make, and libSSL dev. Those are the most important ones that are used, especially the make package. It's really important in order for you to continue to set up your kernel. And the most important file is the .conf file. I'll be showing what it looks like in a second. But what happened is there's a graphical interface that are going to be used to customize the kernel. And it's going to reflect everything that you do to that graphical interface to this conf file. Again, if you want to go nuts, you can go to the conf file and customize it directly from the text file. It's up to you. It's just too much information. And another thing that it's important it's for you to know it's that is a bunch of conf files that you can find online. So you can use those as a reference for your environment. So you can go and find, for example, okay, I would like a kernel conf file for 6.7 to run on Azure and for containers. You can find something like that available on internet, and you can use that file as a reference, and then you can go and customize that file and to make it more compatible to your scenario. And yeah, it's just how it looks like. So let me move one slide forward here. And then the first thing that we're going to do, we are going to go to the kernel, to to my Linux server. This is my Linux server. I already have the kernel compiled here, as you can see. I'm running
Is there a
6.7
way
here because
is there a way to try and increase the size of the text?
yes, um, sessions,
Yeah,
settings,
settings,
and then
appearance, maybe.
Windows keyboard, the line vertical. Let me give me 1 second here.
No worries.
Okay, so I'm gonna need to create a new session, and then I go to the default settings, and then appearance, and then change, and here, let me see if I can go there. Okay,
There we
is
go.
it good enough?
Yeah.
Okay, so unfortunately, I'm not be going to show the entire process from scratch because it takes hours to run. The Linux kernel is huge. As I said, there are modules for almost everything, and it would take a long time for us to
Right.
to to demonstrate the entire process. But I'll be showing step by step of how the process looked like, and this process was tested before. So if you guys face any issues, please reach out to me. I can help. But there is lots of documentations available online. The best thing about open source, as I said, everyone's help each other. So the best thing about Linux, they share the same kernel. Doesn't matter if you're running Red Hat, Ubuntu, SUSE. Everyone is going to share their comments, and you're going to find documentation for everything. So going back, I'm here in my the home folder of my user. So the first thing that you need to do, you need to go and download the code from that repo. So if you go back to that page, kernel.org, you're gonna come here and you would copy the link address, and you're gonna download the link, copy the link
Right.
for your package here, and then we're gonna go wget, and you're gonna paste that link here, and then it's gonna download the package for you. Once you download this package, I can do that here. It's not gonna take too long. So if I do another ls here, as you can see, my Linux kernel, it's here. So it's a tar.xz file. So it's a compressed file. The first thing that we need to do is decompress that file. So in order for us to do that, we have tar xvf, and then we provide the file name here. It's gonna
Oh
decompress that
wow.
file for me. It takes a few seconds. It's huge because you have documentation, you have libraries, you have packages, configuration files, everything is here. It's not gonna take too long, but I'm gonna cancel it away just because I already have it here available. So once you decompress once you decompress that file, as you can see here, it's gonna create a folder with the same name except for the tar.xz. But in my scenario, I'll be using the 6.7 just because it's the one that I was testing just for fun. You're
Right.
going to use the cd command, that's change directory. Once you change the directory to the Linux folder, if you run an ls command, it's going to show you a bunch of files here. But what's more fun, if you do ls.lh, it's going to show you hidden files as well in a list format. When you list this in a showing the hidden files, you're going to see the .config file. This is the file that I was talking about. This is the file that your system is going to use as a reference to deploy your kernel. So this is the file where you're going to say, okay, I would like the modules for my sound system, for my wireless driver, my mouse, my keyboard, and everything else. Or you can say, okay, I want all this except for wireless sound because I'm not going to be using those mouse. I don't need mouse. So if you do cat dot conf config, sorry, this is how it looks like. So for example, here you have a config x86 debug FPU. It's gonna be enabled. You have this one. I'm selecting just a few modules on it instead of everything. Some others we're gonna see here. They're common, so they are not be deployed. So it's not set for deployment. So I'm not using this library here. So this group of configurations, they are under x86 debugging. These ones are for kernel testing. So you have a few others here, for example, let me go a little bit higher. So should debug routines. This is for cryptography. And if you're going for certificates, so all the libraries that you need, if you're not running certificates, you can just remove those ones from the deployment. If you keep going on, for example, this one here, it's an accelerated cryptography algorithm for CPU for x86. Um, user space interface, sometimes you can take it off. It's also for crypto. And this file, it's huge. So that's why I usually recommend you to use the graphical interface, just because it's more simple for you to do. So the next step that we're going to do, we're going to use sudo. Sudo is a command to elevate your permissions to a root. So you have an administration privilege in order for you to run the commands. So for example, I'm using my AZ admin, but it's a regular user. I don't have any, I can give you, for example, here, what are the groups that it's part of. So their UID, GID is part of the administration group, but it's not part of the root group. If I do, for example, ID root, you're going to see that's part of the root group. It has all the privilege for the system. When you run sudo, you can customize sudo. By default, if you run just sudo and the command, it's going to run those commands with administration privilege. So the first thing that we need to do, making sure that you are in the folder where you have your kernel. So as you can see, I'm inside of that folder that was just decompressed, the linux.67-rc8. And inside of this folder, I'm going to run the command sudo make, let me just get here, so I don't run the wrong command, menu config.
Menu config, right? Okay.
Yeah, menu config. It's going to ask you for the administration password, because I'm using sudo. So, sorry, one back. So this is the screen that's going to be shown for you. So as I showed you in the config file, each one of those, for example, was showing you the cryptographic API. That was the part of the module that I was just showing you in the config file. If you go inside of the config API, all those configurations that were under the config API are here. So here you can enable or disable or create a custom configuration for each one of those modules. And it's what's going to do is reflect this configuration that you're implementing this GUI to that config file. So in the next step, you're going to be compiling the kernel just with the information, just the modules that you want. So when you see the asterisk, like this one, disable runtime self-test, it means that feature it's going to be completely enabled. When you have the M here, it's modularized as a feature. So you're going to be deploying just some of the resources, but not everything. For some scenarios, it might be relevant, but most for the customization that we're going to be running today, we're going to be all or nothing. So in order for you to navigate, you use your arrow keys and you use your tab, or you can click sideways in your arrows. In the bottom, as you can see, you have select, exit, help, save, and load. If you are not sure about what that part of this GUI do, you can go to help, and okay, it's gonna give you an overview what is that part is about and all the information about it. Because I'm in a high level part of this code, that is a lot of information, but if you go deeper dive, you can get more customized information about the modules. I'll be showing that in a second. So the first thing, now we have the make menu config open. Now we are gonna do some general kernel customizations. So I'm gonna be showing you how you do that from here, but I recommend everyone to spend some time. So if you go here to general setup, there is a bunch of information here. And as I said, if you want to select or deselect, you can use your space button to select or deselect. So asterisk or nothing. And every time there is an arrow side on the right side, it means that there's a submenu under that item. So if you click enter, it's going to take you to that submenu. So for example, the first thing that you can do, you have here the kernel compression mode. You can choose here many types of kernel compression mode. When we talk about performance for containers, I usually recommend ZSTE. I did a few tests in my environment, and it's the one that works the best. So I usually select this one. Another thing that you can do here, for example, I'm not using POSIX max HQ, so you can come here and disable this feature. Mine is already disabled because, as I said, I already compiled this kernel with this configuration, but previously, by default, it comes enabled. Another one, you can come here. There are a few other features, for example, the audit support. You can come here, and if you're not using audit for your system, you can come here and disable audit support for example, here or timer subsystems. Another thing that you can do, for example, for the CPU, task, and time status accounting, if you go here inside, I usually disable the, let me see here, what is the one that I disable? Timer, PSD process account. Not here. Let me go back one here. Let me guess another one, kernel log. Another one that is important for us, it's the timer subsystem. Going down. Right here.
It's amazing the different options,
The
right?
kernel buffer size.
Yeah.
Yeah.
So what you're
For
saying is you
example,
can just
for the
like
kernel,
you can swap out all the settings, right, and just customize the kernel to what you actually need. I didn't even know this existed, so this
yes,
is
correct.
pretty new, right? But I like the whole fact that you can just go in here and basically spacebar it or add it or remove it, right, depending on your requirements. I take it there's a lot of scope to break things as well if you don't know what you're doing, right? So you just got to be
Yes,
careful, right?
that's why. That's why I recommend people that are not familiar with this process to get the config file from the internet with someone that tested it, and
Right.
then you can test and see the compare the results yourself before you deploy it in production. But just one example here. For example, we have the kernel log buffer size. This one is an important one when we talk about containers. I did the test. I got a good performance using 16 for the kernel log buffer size and 15 for the kernel log buffer size contribution. If you want more information, you can go here to help, and it's going to show you an example of how it looks like. So if you set, for example, 16, it means your kernel buffer size is going to be 64 KB. And you can also go here and change that number. But if you go to the help, you can see a few more information about what the packages are dependent on this one, what is mandatory for you to do, and what is the results of those changes. And the same here for the kernel log buffer size. If you go to the help menu, there is information about that module. So I recommend you to come here and read this documentation, and you're going to have helpful information about what is expected on that change. But it's just a demo on what you can do here. But let's move forward for the device and drivers. Just on the purpose of time,
Yeah,
I'm going
yeah.
to be showing the device and
I
drivers
didn't want to say anything,
here.
right? But here we are running out of time.
Yes. But from here, it's where you can disable most of those drivers that we were talking about. From here, you can find here, for example, the wireless driver. You can come here and disable the driver for wireless. You can disable driver for example, sound wire support. If you don't need support for sound system, you can come here. Okay, I want to disable my support for sound. Um, Another one that I recommend, for example, it's everything. If you're running on Azure, most of the hardware it runs on top of Intel servers. So everything that you see here that's AMD on it, you can basically, I recommend you double checking. For example, if you go here to generic drive options, there is some important things here. PCI support, same thing. But I recommend you checking everything that you see that is AMD on it. You can basically go and disable those
Yeah.
if you're running your servers on Azure, and should be good for you to go. And it's gonna save you. You can do some hardening in your system that way. And then once you finish those customizations, just going back to the slide deck for a second here, I have here an example of customizations that we can do. for example, timer subsystem, CPU task status, I usually disable support to BSD because we're not going to be using that. For the initial run system, I usually disable everything except for GZ, PZ2, and ZSTE for the compression of the RAM. If you go under the processor type and features, I usually enable Intel support and I disable the AMD support. This is the one that I was talking about. If you go here to the processor type and features, you're going to see here AMD, for example. This is an example of an AMD feature that you can disable. And you also have support to BSD features. Most of the time, you can disable that, but again, it depends on your scenario. So just double check if it's recommended for you to do that. Some other features that you can disable here, processor family. Usually it comes by default by generic x86, but if you're running on Azure, I would go Core 2 or near Xeon servers. It helps with your performance a lot when you enable that feature here as well. So you go to the processor family. Let me just scroll down here. Processor family. Those are the options that we have. So we have Atom, we have the Intel P4, Optium. Those are for the AMD. If you are not sure which one are going, if it's AMD or Intel, I usually go for generic x86 64. It's the most generic one. It should work for everything. But if you're on Azure, I deeply recommend you going to Core 2 or near Zero. It's going to provide you the best performance for those CPUs. Again, disable all the AMD features. If you move forward under power management, I would usually recommend disable. If you're running a performance server, you don't need standby. You don't need to hibernation. So I usually disable those features to make sure that my computer is gonna run full boost, full performance all the time. And the CPU frequency scale, I usually disable power saving. Again, I disable AMD features if I'm running an Intel server. It also helps you getting some performance from your memory and also your CPU. Moving forward, we have block layer configuration. We can disable debug FS. Debug FS, it's used for the debugging of the kernel. If you're not helping the development of the kernel, there's no need for you to have the debug FS enabled. But if you are the kind of guy like me who wants to go deep dive on the debugging of the system, you can keep it up. But for most of the people, it's not necessary. Under networking support, I would go and disable wireless. Under device driver, I would disable PC card. For missed devices, disable everything that I do not use. SCSI device, I would enable asynchronous SCSI scanning. This one, sometimes it comes, if you use the Azure image for your service, if you go to Azure Marketplace and select any one of the flavors of Linux that we have available there, they come with this feature enabled by default. But if you go to the Ubuntu webpage or Red Hat webpage and download, your kernel most likely will come with this one disabled. I did a few tests myself, and it actually helped the boot performance. And if you usually want a fast boot performance for your environment, and this feature helps you on that, I would disable, if you're not using RAID controllers, if you're especially using containers, it's usually not required. I would disable that one as well. And I would disable Macintosh drivers as well, because you're most likely not be using those. For device operations, we have network device support. I would go disable wireless one more time. I would disable USB adapters. I would enable, if you need a VPN, I recommend you to enable WireGuard. It would provide you to support VPN for most of the VPNs available in the market right now. For the input device support, I would disable touchscreen, miscellaneous drivers, and tablets, because you are not running the Linux in any of those devices. You don't need that kind of support. If there is no support for USB, I would take it off here one more time. For the x86 platform specific drives, I would check all the drivers that are required. So disable sound systems, you can disable mouse, you can disable printers, and a bunch of other things. If you want to improve even more your performance for a file system, I would go and disable if you're not using network file system and miscellaneous file system like Samba or any other of X32 or FAT or some of those different file systems, I would go and disable that here in the under file system as well. And then let's go back to the black screen. So we keep going with the demo. Once you finish all those configurations, what you're going to do, you're going to come here, save, As you can see, it shows you the .config file. You just press OK, and then configuration was written to your config file. So you can go and exit. Sorry. Once you do that, everything that we just did goes to the ls, sorry, cat .config file. That configuration was placed here, so you don't need to come and change everything by yourself. Everything comes from that GUI. That's much more simple for you to do.
Right.
So once you do that, it will create your config file and all the modules that are required. So as I told you, everything that is available, all the libraries, drivers, and everything, it's here in this folder. So what it's going to do, it's going to go through the config file and say, okay, I have all the modules, but I just need A, B, C, E, K, and Z. And then it's going to just take those modules and prepare those modules for the compilation to compile. In order for you to do that, you just run the command make. What make will do is prepare the current those modules to be deployed. So when we run the command make, I can start it here. Oh, sorry, sudo make. You need root permissions in order for you to do this. What it's going to do, it's going to go to the config file and start preparing those modules for deployment. This process takes a long time. I would say hours. You can make it faster, selecting less modules, but most of the time it's going to take hours, but it's not something that you do every day. So once you deploy your kernel with just the modules that you need, you can just update that kernel afterwards, enabling or disabling modules manually. I will be showing you how to do that in a second. But your base system is ready. So you can go to your, let's say, to your Azure portal, and you can create a base image using this OS that with a custom kernel as a base kernel for your environment. And every time you deploy a brand new server, it's going to have just those modules enabled. So you can create an image and deploy all the servers based on that image. And then once you finish your make process, what you're going to do, it's going to do sudo make modules underline install. What it's going to do is prepare the modules for the deployment. So it's going to get the modules and convert from this folder to the system folders. Because, for example, if you go, for example, ls /dev, you have here the devices in your computer. But for example, if you have from the source of your system here, you have your lib environment, so ls/lib. Lib, it's where the libraries of your environment are stored. So from here, you have the libraries for Python. We have your libraries for your init. You have for the Linux code itself. So the libraries are stored here. So what it's going to do is take from this folder where I am right now, the Linux 6.7 folder, and those modules were compiled, and then your code is going to check from the config file, okay, those are the modules that I need. I'm going to move those modules for the specific folders. So for example, your module for group, it's going to take the brand new module for the 6.7 and move to the group folder under lib. And it's going to do that for everything that you select in your environment. So it will automate install those modules for you, moving them to the right folder and applying those modules to your system. But up to this point, it's going to just create the modules and move them to the folder for you. So the command for that is sudo make modules underline install. I'm not going to run this one because I already did. I can just show you how it looks like from the beginning. Again, it's going to take some time, but not as much as the make command, the base one. This one, it's a few minutes to run. But as you can see here, it's taking these modules and installing those modules in my system. So taking from this folder and moving to the right one. And once you do that, the next command is sudo make install. Once you do sudo make install, it's going to actually compile that kernel and install that kernel in your computer. So this one I'm not going to run because it could crash something here, and I already did that. So as you can see, it's already running 6.7. But once you run that command, it's going to take a long time again to run.
Right.
But it's part of the process. Just rely, just wait, and it's going to work. And then the next thing, it's optional. You can customize the group. The group manage the boot of your server. So what do I need to do? If you go to your group, you're gonna be able to see in this /boot/group/group.conf, you have all the kernels available in your system. So let me show you. If you
Yeah, I've
do
seen
that,
this. I've seen this before, right? Like back in the day when I was running Red Hat or whatever, I used to be able to select the kernel version because, say, if I updated to the newest one and
Yeah,
there was bugs or whatever, I could just go back and launch the older version of the kernel, right? So,
yeah. If you do an ls to list all the content in the boot folder, this is the kernel itself. So everything that starts with yum Linux, it's the kernel itself. So for example, as you can see, I have a bunch of kernels in this computer. I have the 5.15 for Azure. I have the 5.15 generic. I have the 6.7 RC8, and I have the 6.7 RC8 old. So because I did compile this kernel more than once to run a few tests here. So let's say, for example, I deployed my kernel with 6.7 and something went wrong. So for example, my network device is not working anymore. Network's not working from my computer. What you can do, you can boot your computer back to the 6.15 Azure, for example, and then you go and recompile the kernel 6.7, including that driver that was missing, and then you can go to group and change your group configuration to the 6.7 again, and then once you do that, your system is gonna boot using the brand new partition. So how you do that? It's, for example, you go to the /boot group.conf, and from here you have all your kernels here. So the
right,
first one here, uh, it's one of the kernels that you choose. For example, this one is the 6.7, as you can see here, and you have the next one here. This one is the 6.7. It's the recovery one, and you have the 6.7 old one, and you have the 5.15 Azure. And the way that you tell Linux what kernel it should boot, it's to get the sequence from here and tell the group what kernel you want to boot. So it starts from 0. So the first kernel that you see here is this one. So if you want to boot the 6.7 or 8, you are tell group, hey, I would like to boot the kernel 0. If you want to boot the recovery mode, you tell group that you want to boot the
right,
kernel 1. And then that way, moving down, you can say, for example, if I want to boot the 5.15 Azure, it's going to be, let's say, 4. You just count from top to bottom the kernels. Um, you can do something like this here. Pipe grep menu entry. So this way, it's a bit more clear for you on the kernels. So for example, the first one is this one. It's this one here. It would be the 0. So the 0 would be this here, 6.7 RC8. And then this one would be 1. This one would be 2. This one would be 3. This one would be 4. This one would be 5. This one would be 6. So if you tell the group that you want to put on 6, this is how you do that. So this is how the process works. And then once you do that, you change the boot order. So update here, and you provide the kernel 6.7 and update group, and then you reboot your server, and your server is going to boot using that new version of the kernel that you provided. If something goes wrong, let's say your new kernel is not booting, it's going to pop up a screen for you. Hey, this kernel is not booting, but I saw that you have 3 other kernels would like to boot another one, and you can just choose from the boot screen. You can choose, for example, 5.15 and boot from
right,
that kernel. Unfortunately, Azure doesn't provide you an interface for you to do that for yourself. You can get a print screen of that screen, but you cannot go and change the boot order. So I highly recommend you, before changing the boot order, take an image of your server, and then you reboot. If something goes wrong, roll back your change, uh, make the fixes before you try to reboot it again and take another image. It's not that expensive.
right.
So once you reboot your server, what you want to do, you want to do uname minus -r, and you're going to see that your kernel version changed here. So now it was a 5.15 server, as you saw here. It was my previous version was 5.15, and now it's 6.7 or 8. And now the last part of your presentation today, Linux provides you some opportunities to do a live customization. So the live customization, it's could be implemented 2 ways. The first way would be for you to change the environment variables. So the environment variables, it's like the customizations in your kernel that you can do in order to improve your performance or to enable some features. So for example, if you run sudo cctl -a, it's going to list all the customizations that you can do for your environment. For example, the minimal free kbytes, it's this one. I can go and change this configuration. Or you can, for example, my memory FD no exec, it's 0, you can change to 1. Oh, but I highly recommend you to understand what which one of those configurations is doing before you start implementing those changes. For example, everything that starts with net is a customization for your network interface. Everything that starts with kernel, it's a customization to the kernel itself. And everything that is a VM, it's a virtualization change that we are doing to the virtual machine. And everything that starts with user, that's a customization for the user. So you need to have an understanding of what you're going to do, but then you can customize those chains. The way that you customize those chains, for example, let's say I want to just test a configuration. I can do, for example, a sudo cctl, and then I provide, for example, the vm dump test. It's just a dump virtual machine, so I can do whatever I want here, and equals the value I would set 0. And then now that value was set to 0. If you run just this command, it's going to show you the value that was there, that is set right now. If I set to 1, now it's 1. So you can live change those configurations. Important thing, if you do like this, it's a temporary change. If you reboot your server, it's not going to come up again after the boot process. If you want to make it a permanent change, what you need to do, you -w to write this configuration. Once you do that, once you reboot your server, this configuration is going to be permanent. So this is the first way for you to do that kind of change. And just an example here of how it looks like. So when you do the process of change, you run systemctl and then the class and the tuning itself. So for example, it's a VM, it's a user, it's a kernel change. What is the tuning that you are doing and what is the value? And what it's going to do, if you type -w, it's going to replace that configuration to the cctl.conf. Let me show you how it looks like. So etc cctl.conf. In this file here, all those customizations that were available when I typed systemctl -a, they are here. And you also have some information on what the setting is going to do. For example, you have this one here, net IP v4 config all send redirects. And there is a description on what this change is going to do. So I recommend you to come here and see what is that change and what is the impact of implementing that change to your environment. If you type systemctl -w, that change is going to be implemented here. And so it would remove the comment, the comment from here. And when you reboot the server, that change is going to be applied permanent. But you can disable that feature live as well. So let's say, for example, want to test one of those features. You go change, you test, for example, the performance, you keep monitoring CPU and memory utilization, for example, and then you implement the change, run the same process again, compare the CPU and memory utilization, and you know if that change has an impact or not. Sometimes it's going to block your connection. You know that what you need to roll back in order for that to work. So this is how the CCTL works. When we're talking about implementing the performance for the containers, I have here a few examples what we can do in order to improve the performance for your containers. For example, most of the containers, they need lots of connections. You need lots of users connecting to your application. So what I would do, I would implement, for example, increase the number of connections. And those are the variables that you need in order to implement that change in your environment. So you need to change a net core sum xcon, IPv4 TCP max scene backlog. So you have more connections coming up starting in your environment. And you have also changed the maximum number of connections in your device. And you also have the keep alive. I would change the keep alive process. It's sometimes problems that you have when you have a queue in your environment. Keep alive, if you increase the keep alive, sometimes you block the connections to be dropped, especially if you have connections environments where you have an application that is session persistent. I would change the keep alive because you need to keep that session available for longer. Another one, net IPv4 TCP fast open. This one is a mechanism to establish the connection sending the SIM package, and it improves the latest of your workloads. And a few examples of what you can do: RMAM, WMAM, TCP RMAM, TCP WMAM, and MEM2 probing. And I gave you a few examples of how you can do that configuration here on that in your environment. So you can use -w, or you can go straight to the cctl.conf file. And I have here recommended values that I tested in my environment in order for me to improve the performance. But one more time, it's a test that I did in my environment. It was just a dumb environment. Everyone should test their one configuration and see what is the recommended value for them. And you can search for recommendations online as well. Another set of configurations that you can do, you can disable swap. In order for you to disable swap live, you can do swap of -a. It's gonna go and disable the swap in your environment. And another way for you to do, but it would be a temporary configuration. If you go to etcfs tab, if you have swap enabled in your system, it's gonna show here. So you can go here and disable swap from FS tab and then make that change permanent to your environment. Swap, it's a temporary memory in your disk, so it emulates your RAM, or your physical memory in your disk or your SSD device, but it's not as performant as a real RAM. So I recommend disabling that one for some environments. Another change that you can do is change the limits. So limit, it's some of the things that we can do in our environment to improve the performance. In order for you to change the limits, you go to etcsecuritylimits.conf, and that is a bunch of recommendations on what you can do. You can change the soft and the hard limits for environment, and you can change using unlimit -n. So you would remove all the limits, but it's dependent on the session. So you need to log out and log in again in order for you to do that. So etcsecuritylimits.conf, and from here you have the limits by user. So you have the soft and hard limits for your users. So you can, I would recommend you changing for the users that you're using for application and the users that are handling your container orchestration. You go here and change the limits. And I have here a few examples of how you can do a 1 to 2 400 for soft and hard limit. It could be a good number depending on the environment. This is also something important for you to run. Another few changes: I/O schedule. It would help you with the performance of your system. The kernel performance, it would be kernel.pid.max_max. It increased the maximum number of process or namespaces in your environment. FS, I notified max user watchers, increase the maximum numbers of I notified watchers. And lower time, also disable access to time updates. It's sometimes help you to increase the performance of your system. And it can be disabled in the fstab file as well. And also the deadline or loop are recommended depending on the configuration that you have in your system. Deadline might be recommended for your schedule, but you can also use the loop if you're running for SSD. If it's a non-SSD, deadline would be a good one. And you can run that change here in the sysblock device queue scheduler as well. It also helps with the storage performance of containers. It relies on storage in order for it to work. And the last part of this presentation, we disable the modules in our system, but Linux also gives you the opportunity to enable or disable those modules live as well. So if you go to usr lib modules and your kernel version /kernel, you have all the modules that you have available, and you can load or unload those modules. In order for you to do that, you can list all the modules running ls-mod, and you can use mod info in order for you to enable or disable those modules. And for example, for those modules, it could be anything in your environment. So for example, in order for you to list all the modules available, so let me just show you here. So ls-mod, it has all the modules available in your system. It has one, it's enabled. If it has 0, it's disabled. And here are the processes that are running that module. So for example, for this helper here, it's used by my Hyper-V process. So I have here this one xtables, it's enabled, and it's used by my iptables. So you can enable or disable those modules as well. And this is the list of them. And if you move forward here, you can enable or disable the drivers as well using mod probe. So for example, you can go and enable and disable CD-ROM from your computer. So you would need just to run mod probe IDE underline -cd, and you would be enabling or disabling that module. And you can also provide parameters. For example, for this one here, I have a mod probe start underline RO equals 1. So it means that this module will be starting in read-only as 1, so it read-only to be enabled. But you don't provide any parameter, it's gonna come as the default value. But for example, for the CD-ROM, you would like that to start as a read-only. And then, in order for you to list all the modules, you can go to etc modules, and you can include in the etc modules file itself, or you can go to the conf file. So let me show you how it looks like in a real scenario. So if you go to etc modules, so you have here the modules.conf, and from you can add your modules here. Or if you want to segment, you can also create any file that you create under this folder with the extension .conf. It's gonna be used as well. So for example, there is one just for Hyper-V. So if I print the result here, it means that during the boot of the system, it's gonna load the HV stock module. And also there is another file here that it's going to load these three modules. I can create another file here, for example. Let's say this hvnet net vsc module. I can create, for example, avsc.conf vi, and then I can come here and enable and add this parameter here and save it. Oh, I forgot to use the sudo. Oh,
I do that all the time. All the time. I forget to put like sudo vim or sudo nano, right?
Yeah.
To edit a conf file.
Yeah, and then ask
WQ
2
bang.
points W key.
Yeah.
So now if I list the content here in this folder, as you can see, I have this new file here. And then if I print you can see this module inside. So it means right now this module is disabled, but if I reboot my computer, it's going to enable this module during the boot process. And this is how the modules work. And if you want to remove a module that is in your environment, for example, I don't want that module anymore, you can use rm mod, so it's going to remove the module.
Right.
Or you can use mod probe -r. It's going to do the same, different ways to do the same thing. And some modules cannot remove live, so what we need to do is remove that module from the config file. It could be the main config file or the specific config file. As I showed you, I just created one, so you need to find that module name in the config file. And a simple way for you to do that would be grep and then provide the module name. And so if you do that, it shows you what is the file and that this content inside of that file. So if the same module is in 2, 3 files, it's going to list here all 3 files with that module. So it's a simple way to find if there is a configuration file with that module enabled. This is how you can find that information easily. So, and then you remove and reboot the system. It's just because some modules are not allowed to be removed live, but it's usually for kernel modules, most of the modules for drivers. As long as they are not in use, you are able to remove them live. And I recommend you guys to read the documentation. As most of you know, if you run man and the command on Linux, you have the documentation about that command. So for example, man ls mod, there is the entire documentation on what is the description of this command, what this command do. Most of the time, there is an example of how to run that command. So for example, rm mod, there's here the step-by-step of that command, the description, what are the options that you can use. So you can use verbose. Sometimes you can use force. You can send the information to syslog if you have syslog set up to your computer. And you have also recommended to check the man page for mod info. Sorry for taking so much of your time. If someone wants to reach out to me, please feel free. I'm on LinkedIn. Just search for Guil Lima. It's easy to find. I'm probably using I love red t-shirts, so it's easy to find me. I'm gonna be something wearing something similar to this one.
Gil, that was awesome. You took me back to school. I didn't even know you could do half that stuff, right? Like I normally just use the distros, right, off the shelf, whatever's given to me, kind of thing. But you've shown that we can customize the kernel, how to recompile the kernel, the different modules that we have enabled, and what we should disable, right, to improve efficiency and attack surface. But I was just blown away. That was like, but like you said, like compiling the kernel, it's like compiling any software package, right? Because it's so big, it's going to take time, right? And it's going to be on a bespoke case, right? So it's all dependent on how powerful the computer you're running it on, et cetera, et cetera. But yeah, if you want to reach out to either of us, we're on LinkedIn, Twitter, but you can find Gil on LinkedIn. Shared the link before. If you just search for Guil Lima, you should be able to find him. But again, thanks everybody that's watching. Thanks for if you like the content that we've got, please like and subscribe to Code to Cloud or follow us on social media as well. Again, Gil, I want to thank you for presenting. Well, hopefully we can get you back in the future.
Yeah, you're welcome. I'm glad to be here. If anyone needs any help, just let me know.
Awesome. Well, thanks for watching. We'll catch you on the next one. Bye for now.